Okay, we're talking about absolute extrema, and there's a couple of things to write down on there if you're writing. If f is a function and c is a number, then f of c, and what you need to really have in your head, f of c means the y value that's attached to c. It is an absolute min if f of x is greater than or equal to f of c. That means if the rest of the function is greater, then that thing's got to be a min. That should make sense. If the whole function's greater than that f of c, then f of c is a min. And likewise, it would be a max if f of x, everything else is less than f of c. Does that make sense when you hear that or think about that? I know you try not to think about it, but move up a little bit so we can get that next one. The next thing is the extreme value theorem. Anybody heading on into further calculus, you're going to see that theorem and definitely work with it. So we put it in here. It says if you have a continuous function f on a closed interval, and they'll usually do the closed interval with brackets. So a comma b, that means from point A to point B, you're going to have both a max and a min in that interval. Regardless of what the interval is, you will have a max and a min. So I've drawn two little different graphs here. And from A to B, from here to here, we do have a max and a min. Now, sometimes, I guess if it was, you ended up on the same, no, ignore that. So here's a min, here's a min, here's a max in this particular interval. Here's a min, here's a max in that interval. Doesn't mean it's the absolute max of the whole function. It means where we're looking from A to B, you're going to have a low point and a high point. Okay? Now, there's some steps for finding absolute extrema on an interval, because that's going to be partly what we do in our problems. So there's the steps. Okay. So you're going to find all the critical numbers within that interval. So you're given some function. You're going to find the critical numbers. How do we do that? How do we find critical numbers? First derivative, set it equal to 0. So we'll do what we've been doing. Nothing new there. And then you're going to evaluate f for all those critical numbers. Okay? It's kind of like we'll make a little chart. We'll say, okay, my critical number's this, and f of that would be this. So we'll do that. You also have to evaluate f for the endpoints, for A, for B. And they're going to give you that interval. So you'll know what A and B are, and you'll evaluate there. Then you're going to look at all of those things. If there was one critical number, how many things would you be looking at? You'd be looking at 3. You'd be looking at A and B and the critical number. Okay, and the largest one that you find in step 2 or 3 is the absolute max. The smallest value is the absolute min. So the only thing that we've added here is that we have to evaluate the endpoints as well as evaluating critical numbers. So we're just going a little bit further with this idea of using the derivative. Questions on that? Okay, if you want to be getting your problems, we're going to be looking at those. And the first two are really just analysis type questions, so we will be looking at those. I don't have them on the screen, but we'll talk about them. Everybody through writing? Can I switch to the other? Okay, that's number 3. I don't have number 1 and 2 on the screen, so let's talk about number 1 and 2. Number 1 says identify the labeled point on the graph as an absolute min, an absolute max, or neither. It will be a pull-down menu on MATLAB. So what is that thing where x1 is? Absolute max. You're just looking at it and you're saying, okay, that's an absolute max. It'll be a pull-down. You'll choose absolute max. Okay? Number 2 gives you 4 things. Remember when we first looked at this, I had a picture drawn. When we were looking at maxes and mins, I had a picture similar to this. And so there's 4 pull-down menus. X1 is what? Absolute max, because it's the highest between X1 and X4. X2 and X3, are either of those a max or a min? So their choice would be neither, because that's your only options, absolute max, absolute min, or neither. Okay? And then X4 is what? Min. Okay? So those are 2 that I just threw in there to just get you looking at it. That's not the calculus part. You're just recognizing what's a max and what's a min. Okay? All right, then we're going to go to number 3. And number 3 I do have on the screen. And this is what the problem looks like. They give you a function, x cubed minus 2x squared minus 15x plus 5, and then you're given an interval, -2 to 0. -2 to 0. So remember the steps. First we take the derivative. So that's what's happening here. The derivative of that thing is 3x squared minus 4x minus 15. Once you have the derivative, you're going to set it equal to 0. So set it equal to 0, and I factored it, and I came up with 2 values. Those would be the critical numbers. These are critical numbers. Okay, now I've marked out 3 because 3 does not fall in this interval. So I don't even have to consider it. My interval ends at 0. So I marked out 3. You need to definitely check the interval that you're supposed to be evaluating. Okay? So the only critical number I need to include is -5/3. Are we okay with that? Okay. So then I made this little chart. You should have x on the left, f of x on the right. And you list the critical numbers and the endpoints. And you should do them in order. So I start on the left side of the interval, that's -2, and I ended with 0. If there were 2 critical points, I'd put them in between. I just have 1, -5/3. And then you're just going to plug these numbers into F and get a number over here. So double check and make sure that you can get these numbers when you plug into the original function. So you're plugging into x cubed minus 2x squared minus 15x plus 5. And let's make sure you can get 19, 19.81, and 5. Be sure that you can do that. Anybody need a Oh, I didn't bring my calculators. Do you need one, Drew? Because I can send you down to my office and you can grab them. You want to go grab them? Okay. And in MATLAB, they're going to want a fraction. So be sure that if you get 19.81, does it convert to this? Somebody try that for me and make sure. It does? Okay. So this is what you'll want for MATLAB. So you're plugging into the original and you're getting the numbers on this box. Then you're just looking, what's my biggest one? What's my smallest one? 19.81 is the largest, so that's my max. 5 is the smallest, that's my min. Okay? Questions? For this one, did you turn it into a fraction? And did you get this? Did somebody else say they did get it? Did you have more digits besides 19.81? 1981 over 100. But you got it? Very weird. No. I don't have my calculator. Yeah. Thank you. Okay, so the question was about converting this to this. I want to have that on the video. So when you actually plug in -5/3, you're going to get 19.81 with some other digits. At that point, hit math fraction, and you should get 535 over 27. So don't round it. It's rounded for this little chart here, but don't round it before you turn it into a fraction. Okay, thanks for pointing that out. Okay, let's look at number 4. Number 4 has f of x equal to x to the 4th plus 18x squared minus 81, and our interval is from -4 to 4. Okay? So first step, we take the derivative, which is here, -4x cubed plus 36x. And then we're going to set that equal to 0. I have -4x cubed plus 36x equals 0. I factored out -4x. That's the way you want to work with this one. And so -4x and x squared minus 9, those are your two factors. Okay? And you take each of them and set it equal to 0. And of course, when it's just -4x, that's going to become x equals 0. X squared minus 9, you get x equals -3 or +3 when you do that one. So how many critical numbers do I have? 3. Okay, so are they all within this interval?
Yes.
Okay, so I'm going to have to evaluate -4 and 4 and then everything that I found here. So I'm going to make my chart like that. Those should come out even like that, I believe. So I put them in order, -4 and then -3, 0, 3, and then 4. And you're going to evaluate those numbers in the original function and see what you get. We have two highest points at 0 and 0. So there's our max. Both of them are a max, and -81 is the lowest, so that's the min. Not so bad. Take the derivative, find the critical numbers, evaluate those and the endpoints, and find your max and min. So this is just more application of the derivative is what we're doing. Questions on that one? Okay. Let's look at number 5. Number 5, now we have a quotient rule that we have to do to find the derivative. Okay? But by now, hopefully that's a little better if you're doing that. Okay, whoops. There's the work. Bottom times the derivative of the top minus the top times the derivative of the bottom. Okay? All over the bottom squared. So you end up with 4x squared plus 4 minus 8x squared. So what's in the yellow box ends up being the derivative. Any questions on just finding that derivative? You're going to set that equal to 0. What's going to happen to this bottom part? It's going to go away when you're setting it to 0. So you're really just worried with this negative 4x squared plus 4. So we're going to set that equal to 0 and solve. So if you subtract 4 on the other side, then you divide by the negative 4, you get x squared is 1. And you have x is plus or minus 1. So we have two critical numbers. Two critical numbers. Then you're going to do the same thing. You're going to make your chart. We have an interval. I think it was negative 2 and 2. So both of these fall within that interval. I don't know why that arrow is doing that. And you'll probably get a decimal, but be sure that you can change it to a fraction so that you can get the answer you need on MathLab. Okay? I mean, after you've done a few of these, hopefully the process is down and you can get it. All right? You want to think of 8/5 as 1 3/5, so that's easier to compare to 2 and negative 2. All right, any questions on that one? Okay. All right, this one is a little bit of a challenge on the derivative. So we need to pay attention to this one and what we're doing because we don't see these as often. We have ln x over x to the 12th. What is this? Is it a product? It's quotient. Okay, so we got to do the quotient thing. We don't use ln x as much, so we need to remember what's the derivative of ln x. 1 over x. Okay, so we need to remember those two things. All right, so we've got the bottom times the derivative of the top minus the top times the derivative of the bottom, which is 12x to the 11th, all over the bottom squared. So that's nothing new. It's just you have to think about that ln x thing being in there. When you multiply x to the 12th times 1 over x, what happens? That x can cancel out, and that becomes x to the 11th. So that's just simplifying that one. That's x to the 11th minus, I just moved the 12x to the 11th to the front. And what happened here? X to the 24th. You multiply exponents when it's power to power. Okay, raising power to power, you multiply. You don't add. So this was just simplifying. All right. On the top, I factored out x to the 11th, which left, if you take it out of this one, it leaves 1. You take it out of this one, it leaves 12 ln x. So factor out x to the 11th. Okay, when you so here's our derivative right here. And we're going to set that equal to 0. Well, x to the 24th goes where? Away. We don't have it anymore. So we just have this. And what I did was color code it so you see those are your two factors. X to the 11th is one of them. And then 1 minus 12 ln x is the other one. You're going to have to remember some algebra to do this part. but that's what we're about to do. What's this one going to give you? If you set that equal to 0. Just 0. So this guy's going to give you 0. Whoa. Too big. Too much. Sorry. Okay, so that one gives you x is 0. Now, when we do this one, let's follow the steps. I'm going to subtract this 1 to the other side. So I have negative 12 ln x equals negative 1. Then I'm going to divide by 12 on both sides. So now I have ln x equals 1/12. ln x equals 1/12. If you think back to algebra, and I know it may have been a while for some of us, if you have a natural log function and you want to solve that, you raise everything with e as the base, because e and ln will cancel each other out. So that's what happened here. I said, okay, e to the ln x, e to the 1/12. E to the ln x, the e and the ln cancel each other out, and you're left with x. That's why we have to do that. And then you have e to the 1/12. If you do e to the 1/12 on your calculator, do that for me, because you'll have to do second ln, you'll have a caret, and you'll do parentheses, it'll be a parentheses 1 divided by 12. So e to the 1/12 should get you 1.0869. Okay, so there's our critical number. Now, did we, what was, I didn't write it down. What's the interval on this one? There is no interval? Okay, so this is just everywhere. Okay. Well, why didn't I? Okay. Why am I not including 0? Look at if I put 0 here. It'd be undefined. So let's not worry about that guy right now. What did I do here? I put x equals 1.0869 as my critical number. I said, okay, on the left of that, it's anything below that. On the right of it, it's anything greater than that. And then I have to do that test. So I can try f prime of 1, f prime of 2. I get a positive and a negative. That means, okay, that's an absolute max. Okay, it's a max of 0.0307. Where did this number come from? Where did 0.0307 come from? Plug this value back into the original, and you'll get this. Plug 1.0869, or you could just use e to the 1/12 if you're just doing it on the calculator, and you should get 0.0307. So that's the max, and you don't have a min, so you'll type in an n for that. So there was definitely some algebra in working with that derivative. It's a good reminder. Good reminder. Okay. Number 7. 7 is talking about profit, total profit in thousands of dollars from the sale of X 100,000 pillows. So every time you see an X, that's actually in 100,000. We need to remember that. And then it gives you a function. What is the X greater than or equal to 5? What is that? What's that for? Is that a parameter? It's just saying we can't have less than 5. So we have to remember that. Okay. Find the number of hundreds of thousands of pillows that must be sold to maximize profit. We're going to take the derivative. We're going to find out where the max is. So, here's the original function. You're going to take the derivative of it. We get that right here. Negative 3x squared plus 24x plus 99. That's the derivative. We're going to set that equal to 0. However you want to factor that is fine. I always try to divide out any number that I can get out of there to start with. So I took out -3. That left me with x squared minus 8x minus 33. That makes it a whole lot easier to factor. Factors of 33, 11 and 3, that also makes us 8, so we're good. But I got a positive 11 and a -3. -3 is not greater than or equal to 5. So discard him. He's gone. And then you're just going to do what we've been doing. X equals 11, x is less than 11, greater than 11. So I tested 10 and 12 in the original. I got a plus and a minus. So yes, x equals 11 is going to maximize my profit. Does that make sense? Use the derivative to find the max, to verify that that's the max. All right. When x equals 11, f of x equals 10, 10. If you plug 11 into that original function, you get 1,010. But we have to go back to what it said. It was talking about the profit is in thousands of dollars and the x is in hundred thousands. So for the pillows, I had to add a bunch of zeros. And for the profit, I had to do the same thing. You look at your problem, and if it says in thousands of profit, here's this, so I'm going to add 1,000. I'm going to add 3 zeros to it. This is in hundred thousands, so I'm going to add the number of zeros that I need to get that in the correct unit. So if you were to put in 11 and 10, 10 as your answers, you'll get it wrong. You need to have it with the correct zeros. Okay? So maximizing profit, same thing. Derivative, critical numbers, test it, we're good. Questions? It's kind of the same thing over and over again. Try to stay awake. Okay. The last one, we get a little bit something new. Average cost formula. You probably want to write that down if you're taking notes. If you're just watching, remember to note that when you get it. It's got a bar over the C. So average cost is the cost function divided by x. Cost function divided by x. And it says find the minimum value of the average cost of the given cost function on the given interval. So there's two parts to this. The first one says between 1 and 10, if x is between 1 and 10. So the first thing you have to do is take the cost function you're given and divide it by x. So that's what I've written here. And the easiest way to simplify that is divide x into each piece. So x into x cubed becomes x squared. X into 30x becomes 30. X into 128, well, that's just 128 over x, but for derivatives, it's easier to write it this way. 128x to the -1. Does that line make sense to everybody when you're simplifying? So here I'm taking the derivative of the average cost. So that becomes 2x, the 30 goes to 0, then I have -128 to the -2, x to the -2. So that's the easy way to do that, but then it's easier to solve it if you put it back in fraction form. So when I wrote it this way to set equal to 0, I rewrote that back to 128 over x squared. So in order to solve that algebraically, you want to multiply through everything by x squared. When you multiply it there, you get 2x cubed. Here it makes the x squared go away. So you end up with 2x cubed minus 128. I'm going to divide everything by 2, and that leaves x cubed minus 64 equals 0. Okay? Add your 64 to the other side, so you have x cubed equals 64. Cube root of 64 is 4. So that solves down to x being 4. You can do cube root on your calculator. It's under math. One of those little functions under the math key has a cube root, a radical with a 3. So you could do cube root of something else. 64 is one you might know. All right, so we're going to evaluate average cost x at endpoints and critical numbers. So here was my critical number. Here was my endpoints. I'm trying to find the minimum within that interval, and it is at 4, and the min is 78. Okay, you try the last part of that question, because all that's happening is your interval has changed from 10 to 20. So you don't have to do the derivative over again. You're just going to have a different chart. And is our critical number in the interval? No, critical number was 4. So you're testing 10 and 20. So if you guys would do that, we'll get the last part of that question done. You should find that 10 is the minimum. Questions on those? Anybody? You know, the things that you're going to encounter on Math Lab are these kinds of problems. That's why I'm giving you these. But really, if you understand the process, regardless of what you're given, you should be able to think about it. Okay, I've got to take the derivative, find the critical numbers, use the endpoints, and evaluate. So hopefully that will do that.